Good morning, everyone. Today we're going to be talking a little bit more about distributive property. I know we've gone over it a bit here and there amongst other lessons, but today is going to be devoted specifically to the distributive property itself. So the reason we need the distributive property, or at least the reason it's useful, is let's say I've got this problem right here. Let's say I've got 3 times the quantity of x plus 1 equals 9. The distributive property is what allows me to say, okay, instead of 3 times the quantity of x plus 1, and inside those parentheses right there, I'm going to think of it as 3 times x plus 3 times 1. And it leaves the 9 unchanged. So now once I've got that, I can say, okay, 3 times x is just 3x, and 3 times 1 is just 3, and the 9 is unchanged. And that's the end of where I use the distributive property. If I wanted to finish solving this, I'd go, okay, minus 3 on both sides. And then I'd get 3x equals 9, divide both sides by 3. And then I'd get x equals 3. Then I'd be done. Now, since you've seen how the distributive property works, what you're going to do right now is you're going to pause this video and then Google the distributive property, or you can Bing search it, either way, and write down whichever definition you think is the best one for you, the one that reminds you of what the distributive property does. Okay, glad you're back. Now we're going to copy this diagram onto your notes underneath that definition. This one right here, distributive property, A times the quantity of B plus C equals A times the quantity of B plus A times the quantity of C. And then we've got 4 examples of that. We see 3 times the quantity of x plus 4 is equal to 3x plus 12. And then 3 times the quantity of x minus 4 equals 3x minus 12. And this is where negatives start to come into it. That gives us negative 3x times the quantity of x plus 4 equals negative 3x, because negative 3 times x is negative 3x, minus 12. Because remember, negative times positive is negative. And then finally, we'll even see it with a double negative here, where negative times negative equals positive. Negative 3 times the quantity of x minus 4 equals negative 3x plus 12. Alright, now for one of the newer concepts of today's lesson. Let's call this section on fractal distribution. So this is all well and good for when I'm multiplying times some whole number. It's fairly obvious, but let's say I had one like this. Let's say I had, actually, before I even get to the example, if you have to distribute fractions, make it easier by multiplying everything by your LCD. That's lowest common denominator. This is a strategy that allows us to make an equation like this one in our first example into one kind of like these up here with the green arrows next to them. So let's say we start out with 1/2 times the quantity of x plus 1 is equal to 2. Now, I could do what I would usually do and distribute 1/2 times x plus 1/2 times 1 and get 1/2 x plus 1/2, but there's actually an easier way. Let's look at all the fractal terms, meaning all of the fractions in this problem. Okay, there's only the 1, and it's this 1/2 right here. Now I can get rid of that 1/2 by multiplying times my lowest common denominator. Since I've only got the one fraction, I'm just going to multiply by the one denominator. I'm going to say, well, 1/2 times 2. Remember, anything I do to one side, I have to do to the other. So I'm also going to say this 2 over here times 2. And 1/2 of x plus 1 times times 2 is just going to get rid of that 1/2. So we'll be left with just x plus 1 is equal to 4. And now I can solve the rest pretty dang quickly. I just have to say minus 1, x equals 3. Now for last one today, a little more complicated. Let's say I've got this instead. Example 2. If I've got draw already. 1/2 times the quantity of x plus 2 plus 1 is equal to 1/3 times the quantity of x plus 8 times the quantity, by the way, basically means in parentheses. Well, now I've got two denominators, so I can't multiply by just one of them and get my final answer. One option is, I can definitely first multiply everything times 2, then get my next line of answers, and then I can multiply everything times 3. Or I can ask myself, 1/2 and 1/3. What's the lowest common denominator of 1/2 and 1/3? What's some other fraction that works for both halves and thirds? Well, 20/4 could work, but that's not going to be very fun to multiply times. The lowest common denominator for halves and thirds I can find by saying, okay, 1/2 times 1/3 is 1/6. So I'm going to multiply everything in this times 6. I'm going to go left side times 6 and right side times 6. Now when I do that, I'm really going to have to multiply 3 things times 6. It's going to change this coefficient in front of this parenthesis. It's going to change this other coefficient in front of this parenthesis. And it's going to change this 1 because I'm multiplying everything on both sides by 6. So, since I'm multiplying this by 6, I'm going to say, now that turns into 6/2 times the quantity of x plus 2 plus 6 times 1 is equal to 6/3 times the quantity of x plus 8 and now I'm ready to simplify these terms. So I've said that 6/2 times, oops, forgot my parenthesis up there. 6/2. I know that's 3. So this is really 3 times the quantity of x plus 2. I know that 6 times 1 is 6. I know that 6/3 is 2, so that's 2 times the quantity of x plus 8. And now I'm ready to solve it just like it was one of those ones before. I'm going to use the distributive property to figure out what 3 times the quantity of x plus 2 is and what 2 times the quantity of x plus 8 is. If you feel comfortable with that, you can stop here and move on to the regular work. If you're not comfortable with that, I'll show you how I would do it for this one. So now 3 times the quantity of x plus 2 distributes into 3 times x plus 3 times 2. I've still got that plus 6 equals, and 2 times the quantity of x plus 8 distributes to 2 times x plus 2 times 8. Time to simplify these. 3 times x is just 3x. 3 times 2 is 6, and my original 6 is left alone. That's equal to 2 times x is just 2x, and 2 times 8 is 16. Now I'm going to combine like terms and say 3x plus 12 is equal to 2x plus 16. Subtract 2x from both sides to get an x by itself almost. So I'll have x plus 12 is equal to 16 because those 2x's canceled on the right. Now subtract 12 from both sides to get x truly isolated, and we'll say x equals 16 minus 12 is 4, so x equals 4. Then I'm done. Unless I want to be super sure, in which case I'm going to go back to my original equation, substitute 4 for x, because that was what I found, and make sure that both two sides come out equal. Which theoretically, if I replaced x with 4, I'd get 3 times 4 plus 2 is 6. So 3 times 6 is 18, plus 6 is 24. And on the right, I'd get 2 times 4 plus 8 is 12. 12 times 2 is 24, so I'd get 24 equals 24, so I'd know that I was right.